Hello students, welcome to the part 8 of the chapter Electrochemistry. In this part, we are going to hear about electrolysis and Faraday's laws that govern the principle of electrolysis. So electrolysis, as we have already discussed, has a cell that is connected to two electrodes, one positive electrode and the other one is negative electrode. And these electrodes are dipped in an electrolytic solution. So electrolytic solution means it contains positive and negatively charged ions. Negatively charged ions move towards positively charged electrodes and loses its electrons. That means oxidation takes place, and hence positively charged electrodes are named anode. On the other hand, positively charged cations move towards negatively charged electrodes and gain electron, and that get neutralized, get deposited there. That is, the process of reduction is taking place at the negatively charged electrodes, and hence it got its name cathode. Generally, electrolysis is used for the production of metals. One of its main application is production of metals. So let's take an example. Imagine that the positively charged ions or cations here is sodium. So sodium Na+, which is in the electrolytic solution, will accept electron and get deposited as Na. Sodium plus electron giving Na metal. So it is getting deposited on the cathode. So according to this stoichiometry, it is clear that to get 1 mole of sodium atom, you need to supply 1 mole of electron. So in the electrolysis, if you supply a charge that is equivalent to 1 mole of electron, or if you are supplying just 1 mole of electron, 1 mole of sodium will get deposited on the cathode. So it is like this: 1 mole of electron represents, or 1 mole of electron will initiate a deposition of 1 mole of sodium at the cathode. So what is 1 mole of sodium? How much does it weigh? 1 mole of sodium, it is called its molar mass. Mass of 1 mole of a substance is called molar mass, and molar mass of sodium is 23 gram. So by passing a charge that is equivalent to 1 mole of electron will yield 23 gram of sodium at the cathode. What is the charge of 1 mole of electron? So we are going to calculate the charge of 1 mole of electron. In the case of 1 electron, Q represents charge. Charge of 1 electron we have already learned in lower classes, that it is 1.602 into 10 raised to minus 19 coulombs. So coulombs is the unit of charge, and charge is denoted by the letter Q. So charge of 1 electron is equal to 1.602 into 10 raised to minus 19 coulombs. So what is the charge of 1 mole of electron? If the charge of 1 electron is this, then you have to multiply this value with the value of 1 mole, or Avogadro number. What is Avogadro number? Avogadro number is 6.022 into 10 raised to 23. So this represents 1 mole. So to get 1 mole of electron, you are multiplying charge of 1 electron with 1 mole, and which is approximately, or which is equal to 96,487 coulomb. To make it easy to remember this value, we will round it off, just adding 13 more coulombs, which is negligible compared to the entire number. To make it remember better, we will always memorize this value, that is 96,500 coulombs. So charge of 1 mole of electron is 96,500 coulombs. Here charge of 1 electron and charge of 1 mole of electron is important, and you must try to by heart these values. That is charge of 1 electron, that is equal to 1.602 into 10 raised to minus 19 coulomb, and charge of 1 mole of electron, that is 96,500 coulombs. Generally, this big value is represented as 1 Faraday. That is, 1 Faraday means 96,500 coulombs. Faraday, who is a famous scientist and who has contributed immensely to the field of electrolysis, is honored by giving this unit. So what is 1 Faraday? 1 Faraday is equal to 96,500 coulombs. What is 2 Faraday? 2 Faraday is 2 into 96,500 coulombs. So again, coming back to the reaction, by passing 1 mole of electron means what is the charge now? The charge is 1 Faraday. So if you are expressing charge in terms of Faraday, it is always better to denote it using a subscript. Here charge in terms of Faraday is equal to 1 Faraday. By giving 1 Faraday, I got 23 grams of sodium at cathode. Clear? What happens if I am increase the charge here? Suppose I increase the charge by 2 Faraday. That means 2 moles of electrons. I am supplying 2 Faraday of charge at the electrode. What will be the amount of sodium deposited here? So 1 Faraday gives molar mass, then 2 Faraday gives 2 into molar mass, that is equal to 46 gram of sodium. That means when I am increasing the charge, when I am increasing the supply of charge, there is a corresponding increase in the amount of substance that is deposited at the electrode. So when I increase the charge, there is a corresponding increase in the amount of substance that is deposited at the electrode. Or you can say that mass of substance that is deposited at the electrode is directly proportional to the amount of charge. Amount of substance that is depositing at the electrode is directly proportional to the charge. So when it was 1 Faraday, there was only 23 gram. When you increase the charge, correspondingly the mass increased. So you can say that mass of the substance deposited at the electrode is directly proportional to charge of the electricity. W proportional to Q. When you increase Q, automatically W increases. This is Faraday's first law. Faraday's first law. So Michael Faraday, he is a pioneer scientist in the field of electrolysis. He has also contributed to in many other fields, but one of his primemost work is in the field of electrolysis. There are many other studies before him in the electrolysis. It is not him who has discovered the electrolysis. It is been there even in 17th century. He lived in 18th century, and anyway, it was him who first formulated the laws that governing the electrolysis. So what was the law? It is the same as we discussed in this last slide. Amount of substance deposited at an electrode is directly proportional to the quantity of electricity passed through the electrode. We saw this in the last slide. So amount of substance deposited, that is W mass, at an electrode is directly proportional to the quantity of electricity passed. And we saw the relationship V proportional to Q. So this is Faraday's first law, and V proportional to Q. So when you change this proportionality into equal sign, then automatically you have to add n proportionality constant. So W is equal to Z into Q, where Z is a proportionality constant. Z is a constant for an electrolyte. For a particular type of electrolyte or a particular type of species in the electrolytic solution, Z is a constant. And we know that Q, charge is obtained by multiplying the amount of current passing through the conductor and the time I current into time. Current, its unit is ampere, and time, its unit is second. So if I am passing a current for a specific amount of time, then that current into time will give the charge of electricity passed through the electrolyte. So I can substitute here for Q, W is equal to Z into IT. An important formula to memorize. W is equal to Z into IT. Z is a constant for a particular electrolyte, I is the current, and T is the time. Instead of this, I can also use this formula, W is equal to Z into Q. Now what is the value of Z? This is what we are going to see, value of Z. How to get the value from this equation? Z is equal to W by Q. So Z is equal to W by Q. Q means what? Q is the amount of substance that is passed to get W mass. So Q is the amount of charge or the charge that is supplied through the electrolyte that results in the deposition of a W gram of mass. So Z is equal to W divided by Q of W, or we can write it like this: Z is equal to molar mass divided by N into F. So if you are passing N into Faraday, that means in sodium, when we passed 1 Faraday, N is the number of electrons and F stands for Faraday. 1 mole of electrons, that is 1 Faraday. How much mass did I get? I get 23 grams, which is molar mass. So I can find the value of Z of a substance by dividing its molar mass with N into F, where N is the number of electrons for its reduction and F is Faraday. So this is how you can get the value of Z. So if you know the value of Z, if you know the substance, you will get M by NF. If you know the current value of the current in ampere and time through which the current has passed in seconds, then you will get the amount of substance that is deposited. So this is the application of Faraday's first law to get the amount of substance deposited at an electrode. So this is an important formula. Try to learn. Z is equal to M by N into F. So here in the denominator, if you are multiplying number of electrons with Faraday, normally Z represents a unit that is in coulombs. Z represents a unit that is in coulombs because N into F means it is coulombs. Its unit is coulomb, that is number of electrons into 96,500 coulombs. Value of F, that is 96,500 coulombs. So the value of, or the expression where you will have Z in this formula, if Q is in coulombs, you are supposed to use value of Z as M by N into F. You can substitute this one. Whereas if Q is in Faraday, so here if the Q is in coulombs, Z must be substituted by this formula. Whereas if Q is in Faraday, you are supposed to use this one, m by n. You don't have to convert Z into coulombs in coulomb wise unit. Now the unit is in Faraday. So in the first case, if you want to express, or if the quantity is given is in coulombs, then the equation used for Z to find Z must be this one. Whereas if the calculation involves in Faraday, not the coulombs, then the formula to find Z must be this one, and this is in Faraday. We will see problems using these equations. A solution of copper sulfide is electrolyzed for 10 minutes with a current of 1.5 amperes. So we have time here in minutes, which we have to convert it into seconds, and we have current here, which is 1.5 ampere. That means Q is supplied, and CuSO4 is the electrolyte. So let's see what are the variables that is supplied. So I is equal to 1.5 ampere, time is equal to 10 minutes, which when converted into seconds will be 600 seconds. And since it is CuSO4, we have Cu2 plus in it. Cu2 plus, on accepting 2 electrons, gets deposited as Cu metal. That means number of electrons is equal to 2, and molar mass of copper is 63.5. Now we have the equation W is equal to ZIT. W is equal to ZIT according to Faraday's first law. Instead of Z, I have taken molar mass divided by NF. So if the question is asking for mass of copper and it involves current and time, that means Q will be in coulombs, then I have to use, since Q is in coulombs, IT means Q is in coulombs, M by NF must be selected to get the value of Z. So I have the equation here. I have all the variables that is required for this equation, and simply substitute them. Is equal to, for M it is 63.5, N is equal to 2 into Faraday 96,500 into current 1.5 into time, that is 600, which will be equal to 0.296 gram. So with a current of 1 ampere, if I am passing this current for 10 minutes through the cathode, the amount of copper deposited at the cathode is equal to 0.296. How I got it? By using the formula W is equal to Z into Q. So here in this equation I have substituted for Z. I have used the equation Z is equal to M by NF, which we have seen the last slide, and for Q it is I into T. So substituting, I got the value 0.296. We'll see a similar problem. A solution of nickel nitrate is electrolyzed between platinum electrodes using 5 ampere for 20 minutes. Again, the same method. I is given and time is given, and we have nickel here. What mass of nickel is deposited at the cathode? Same problem. Here M is supplied. In the case of copper, M wasn't supplied. You are supposed to know the value, 63.5. So nickel is 59. So let's see the variables. I is equal to 5 ampere, T, which is provided in minutes, has to be converted into seconds. 20 into 60 is equal to 1200 seconds. nickel will give Ni2 plus ions and nitrate ion. Ni2 plus means for it to get deposited as nickel metal has to accept 2 electrons. So N is equal to 2. Molar mass equal to 59. Again I am using the same formula as I used in the previous problem. So W is equal to M by NF into IT. Substituting, I will get 59 into 5 into 1200 divided by 2 into, so I am substituting for all these. I will get the amount of nickel deposited is 1.83 grams. Okay. So Faraday has actually given first law to find out the amount of substance deposited, and he has provided a second law. Let's see into the Faraday's second law. The amounts of different substances liberated by same quantity of electricity. Again, amounts of different substances liberated by same quantity of electricity passing through the electrolytic solution. Same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. So to understand this second law, let us see a real example. So I have 3 different reactions. In first reaction, sodium accepting 1 electron and get deposited as sodium metal at the cathode. In the second method, or in the second reaction, Cu2 plus accepting 2 electrons and getting deposited as Cu metal at the cathode. And in the third experiment, it is aluminium 3 plus accepting 3 electrons and get deposited as aluminium. So if I am passing if I want to get what is the molar mass of sodium, molar mass of sodium is 23 grams. If I want to get 23 grams, how much charge should I pass through the cathode? So this is actually 1 mole. That means I am supposed to pass 1 Faraday. 1 Faraday gives 23. Whereas in the second case, if I want to get molar mass of copper, that is 63.5 grams, I am supposed to pass 2 Faraday of charge through cathode. Now if I want to get 27 gram is the molar mass of aluminium. If I want to get 27 grams, I supposed to pass 3 Faraday, because it is 3 moles of electrons, which corresponds to 3 Faraday. 3 Faraday gives 27. So amounts of different substances liberated. So these are the amounts of different substances liberated. But next thing what they are telling is by same quantity of electricity. But here it is not the same quantity. The quantity is differing. So what I am going to do is I am trying to make these quantities the same. The first case it is 1 Faraday, second is 2 Faraday, and third is 3 Faraday. Now I am trying to make all the same, like converting into 1 Faraday. So if I have 1 Faraday, I will get the same quantity, that is 23 gram. Whereas in the copper, for 2 Faraday it was 63.5. Then for 1 Faraday it will be divided by 2, that is 31.75 grams. And for aluminium it is 9 grams. So again we will read it. Amount of different substances liberated. So these are the amounts of different substances liberated by the same quantity of electricity. I have passed same quantity of electricity through the electrolytic solution are proportional to their equivalent weight. That means the mass given here is called the chemical equivalent weights. So these are chemical equivalent weights. So if I am passing same quantity of electricity, I will get the chemical equivalent if it is 1 Faraday. So I would say all these underlined in red are called chemical equivalent weights of their respective elements. For aluminium it is 9. So if I am passing 2 Faraday, then imagine that I am passing 2 Faraday in this case. What will be here? What will be the mass here? It is 46 gram. If I am passing 2 Faraday, it is 63.5 grams. If I am passing 2 Faraday, it will be 18 gram in the case of aluminium. That means which is multiples of these chemical equivalent weights. Whatever charge I am increasing, a corresponding increase in the chemical equivalent weights is observed. Now read again. Amount of different substances liberated by the same quantity of electricity passing through an electrolytic solution are proportional. So when I increase this will be increased. So it is proportional to their chemical equivalent weights. How to get chemical equivalent weights? How I got this value 23 or how I got this value 9? Molar mass divided by number of electrons involved, that is 3. 27 by 3. In this case, how I got 31.7? In the case of copper, it is 63.5 divided by number of electrons there. So how to get chemical equivalent weight? E is equal to molar mass of a substance divided by the number of electrons involved in that reaction. So this is Faraday's second law. Do you remember what was M by N in our previous law? It was Z. So E and Z are the same, provided their Z was a unit. The unit of Z was Faraday. If it was in coulombs, then Z is equal to M by NF. Then it is totally different. So E is equal to Z when Z is expressing in terms of Faraday. So in Faraday's first law and Faraday's second law, we have constants. In Faraday's first law, the constant Z in terms of Faraday is the same as chemical equivalent weight in the Faraday's second law. We can assume it like that, though it is not there for you to study. Just an interesting fact. This is what I want to point out. Now straight away we are passing on to next problem. How much electricity in terms of Faraday is required to produce? How much electricity in terms of Faraday is required to produce 20 gram of calcium from molten calcium chloride? So I want to calculate Q. That Q in terms of Faraday. And they said that they have provided which metal has to be produced and from where. So calcium from molten calcium chloride, and how much gram is required. So W they have supplied, that is 20. So let's see the first case. Ca is plus 2 oxidation state. It accepts 2 electrons. That means N is equal to 2. And W is 20 grams. N is equal to 2. Molar mass of calcium, you are supposed to know it. That is 40 gram per mole. Now, what is the equation that we have to use? W is equal to Z into Q. That is Faraday's first law equation. W is equal to Z into Q. What is the value of Z? M by N, because it is in Faraday. So for Z, this equation which is expressed in Faraday must be used. W is equal to M by N into Q. Therefore Q, they have asked for electricity. So Q is equal to, rearranging that, we will get Wn. So we have all the variables here. Substituting that, we will get it is 1 Faraday. So if you are passing 1 Faraday, you will get 20 gram. It's relatively very easy, because if you are passing 2 Faraday, you will get 40. Then for 1 Faraday, it will be 20 gram. It's easy to assume, but I just want to show how we are getting it. If it is a different value rather than 20 gram, we should also know how to. So you have to do the same method. In the second one, 40 grams of aluminium must be obtained. So I have the equation Al3 plus, aluminium's oxidation state is Al3 plus. Just interchange, so you will get the aluminium's oxidation state. And also one thing, aluminium in its compound will be seen only in +3 oxidation state. This we have learned in redox reactions in class 11. So Al3 plus, upon accepting 3 electrons, get reduced to get deposited as Al. They are asking for electricity to get 40 grams charge to get 40 grams of aluminium. So W is 40 grams, N is equal to 3, and molar mass of aluminium is 27, which you should know. Again we have the same equation, M by N, because it's in Faraday. Substituting, so Q is equal to, and we are substituting, and we will get it is 4.44 Faraday. Good. I hope you got got everything here. So next problem is how much electricity is required in coulomb for the oxidation of 1 mole of H2O to O2. H2O to O2. So oxidation means always H2O will give O2. Why? Because here in H2O, O is having -2 oxidation state, whereas in O, that is O in O2, is having 0. This is an element, so its oxidation state is 0. That means from -2 there is an increase to 0, which means oxidation of oxygen. So oxidation of water is always production of oxygen from H2. What will be the other product? Other product is hydrogen. They are asking for 1 mole, isn't it? So normally this formula, when you balance it, it is like this: 2H2O plus 2H2 plus O2. But they have asked for 1 mole, so I am dividing. Here there was 2 and here there was 2. I am dividing the entire with 2. So I will get H2O giving H2 plus half O2. Clear? So now I should know the oxidation number which is getting oxidized. So oxygen in -2 is going to 0. That means oxygen has gained oxidation number, so it is oxidized. So from -2 to 0, how much electron is required? 2. That means N is equal to 2 moles of electron. 2 moles or 2 Faraday of electron is required. They have asked in coulombs, so I should convert this mole or in Faraday into, this is 2 Faraday, then I should convert this from Faraday to coulombs. How can I do it? Q is equal to N into F, that is number of electrons into Faraday. 2 into 96,500, that is equal to 1,93,000 coulombs. In this second question, they have asked to convert or the oxidation of 1 mole of FeO to Fe2O3. First let's see how we will get a balanced equation out of this. So FeO on oxidation gives Fe2O3. If you balance, you will get 4 FeO, but they have asked only for 1 mole. So what I should do? I should divide the entire equation by 4. So what I will get? See, 4 FeO is gone because it is divided by 4. Then FeO plus 1/4 of oxygen giving half Fe2O3. So here there is 1 F and here also there is only 1 F because it's half. So what is the oxidation number of Fe here? It is +2 and here it is +3. That means an increase of 1 electron. So what's the number of electrons involved? It is +1 or 1 Faraday. Then Q is equal to N into F, that is 1 into 96,500, that is equal to 96,500 coulombs. Okay, next a much more simpler problem. If a current of 0.5 ampere flows through a metallic wire for 2 hours, so there is I, they have given I and they have given T. What is the question? How many electrons? So they have asking for number of electrons would flow through the wire. So I have I have T. What should I do? I should find Q. Let's see how. I is given, T is in 2 hours, so I have to convert it into seconds. Now if I calculate Q, I will get the charge of the charge that is flowing by passing 0.5 ampere for 2 hours is 3600 coulombs that has flown. So 3600 coulombs. They have asked how many electrons are there. We know charge of an electron. What is the charge of an electron? Is 1.602 Newton to the minus coulomb. And I have a total charge here. How to get the number of electrons out of this? I know the charge of 1 electron and total charge is given here. How to know number of? So what I have to do? Divide 3600 coulombs, this total charge, using charge of 1 electron. So that is 3600 divided by charge of 1 electron is equal to getting number of electrons, that is 2.2 into 10 raised to 22. Okay, next, how much charge is required in Faraday for the following reduction? Much more simple question. For 1 mole of, you are supposed to answer in Faraday, 1 mole of Al3 plus to aluminium. So for Al3 plus to get reduced to aluminium, you are supposed to supply 3 moles of electron. So for 1 mole you need 3 moles of electron. So this will be, the answer is 3 Faraday. For 1 mole of aluminium you are supposed to supply 3 Faraday because it is 3 moles of electron. And 1 mole of Cu2 plus to Cu, that is 2 Faraday, because to obtain 1 mole of Cu you are supposed to supply 2 moles of electron. So the charge is 2 Faraday. Then 1 mole of MnO4 minus to Mn2 plus. So here MnO4 minus, this is the anion of potassium permanganate. This is one of the famous oxidizing agents which you will learn in detail in D block as well as in your practical lab when you are doing titration analysis, redox analysis. In redox analysis, one of the famous reagent or oxidizing agent is KMnO4. KMnO4. So if you are adding K here, it is KMnO4, potassium permanganate, and it is the anion of that potassium permanganate. This is permanganate anion, and in the permanganate anion you should learn it by heart that Mn is in +7 oxidation state. Can make calculations, you will see that Mn is in +7 oxidation state. You should learn by heart. So Mn is in +4 oxidation state, has gone to Mn2 plus. So from +7 to +2, how many electrons? Will be 5 electrons. You can see it here, MnO4 minus plus 5 electron giving Mn2 plus. This is not balanced. This is an ionic equation and you have learned how to balance it. So it's not important to balance here. What is important is how many electrons are there or are required to reduce Mn7 plus to Mn2 plus, that is 5 electrons. So we have charge equivalent to that, it is 5 Faraday. Next question. In the reaction, this dichromate is acid solution accepts 6 electrons and get reduced to Cr3 plus 8H2O. What is the quantity of electricity in coulombs needed to reduce 1 mole of this compound? So they have asked for quantity of electricity in coulombs. Why? Because here in the reaction itself it is given that there is only 1 mole and it requires 6 electrons. That means for 1 mole of this, how much Faraday is required? 6 Faraday is required. How just you need to convert into coulombs. So simple question. So n is equal to 6, that means there is 6 Faraday. So how to get Q in coulombs? 6 into Faraday, that is 96,500, which will be equal to 5,79,000 coulombs. Straightforward question. Next, there are 3 electrolytic cells A, B, C containing solutions ZnSO4, AgNO3 and CuSO4 respectively, and they are connected in series. So we have 3 cells. One is A, in which we have zinc sulfate, in B we have AgNO3, and in C we have copper sulfate. And the important part is that it is connected in series. A steady current of 1.5 ampere was passed through them. A steady current of 1. So since it is connected in series, if you pass 1.5 ampere, all the 3 cells will get that steady current of 1.5 ampere since they are connected in series. And when they pass through them until 1.45 gram of silver is deposited at the cathode of cell B. In cell B it is AgNO3. So they passed till 1.45 gram of Ag is deposited at the cathode of cell B. How long did so they have provided I and they have provided W. I should find out the time. How long did the current flow? Time I should know, T. And also I should know what mass of copper and zinc. Okay, what mass of copper and zinc were deposited by using the same current for the same time. So they have connected 3 cells in series. Current supplied is 1.5 ampere and the mass deposited in Ag is given, that is 1.45. With that I have to find the time, and using all these variables I have to find the mass of copper and zinc deposited in cell A and C. So in B, let us see first B because its mass is given there. Ag plus, which is in AgNO3, Ag is in +1 oxygen state except 1 electron. So in N is equal to 1 and get deposited as Ag. N is equal to 1. And they have provided current, which means that Q is in coulombs, because whenever current and time is supplied, they asked for time here. Whenever current and time is supplied, then value of or unit of Q will be in coulombs. So which is the formula that I am supposed to use? W is equal to Z into Q. Faraday's first law. So it is W is equal to Z into Q. And which Z should I choose? W is equal to M by NF into IT, because it's in coulombs. So I have to use the equation, that is equation for Z, that is representing coulombs. So W is equal to M by NF into IT. Which are the variables? So first I need to calculate time, isn't it? So I am adjusting the equation, like rearranging the equation, like T is equal to mass, it is given here 1.45, N, I know it from this equation, that is 1, Faraday 96,500 divided by molar mass, it's supplied, that is 108, and I is given, that is 1.5 ampere. I am just substituting all these values. W 1.45, N is equal to 1, Faraday is equal to 96,500, molar mass is equal to 108, and I is equal to 1.5. Solving this, I will get the time required is 863.7 seconds. So I have current, I have time. So what will be the charge? I into T, that is I 1.5 ampere into T, 863 point, that is equal to 1296 coulombs. Here I am converting this coulombs into Faraday. I am trying to convert this coulombs into Faraday. This is to reduce the complication of the calculation, further calculation. So I am reducing. You will understand this when we are progressing. So Q in Faraday, this is Q in coulomb. How to convert it into Faraday is equal to coulomb divided by 96,500, that is equal to 0.0134 Faraday. Now what is the next question? Mass of copper. So now I have Q in Faraday, and in cell C I have the reaction. Cell C, it is copper sulfate, Cu2 plus, upon accepting 2 electrons gives Cu. So N is equal to 2. So this time I have Q with me in terms of Faraday. So I can use the equation where Z is expressed in terms of Faraday, M by N. Earlier it was in coulombs because I and T is provided. So I had to use M by N into F. If F is not there, the equation is more easy, or calculation is more easy. So for that I have converted coulomb into Faraday to use this much more simpler equation, M by N into Q. What is M of copper? 63.5. N is 2 here, and Q, it is given in Faraday. You just substitute all these values. 63.5 divided by 2 is into 0.0134. Substituting all this value, you will get the amount of copper deposited at the same time and current, that is 0.425 grams. What about in cell A? It is zinc sulfate. So Zn2 plus 2 electron giving Zn. I can use the same equation here. So substituting, molar mass of zinc is supplied, that is 65.4 divided by 2 into 0.0134, which is equal to 0.438 grams. Okay,